Hello students, welcome to new session. In this session we will discuss about Gpib, that is General Purpose Interfacing Bus, which is also known as IEEE 488 standard. So let's discuss. Gpib, that is General Purpose Interfacing Bus, was formerly known as HPIP, that is Hewlett Packard Interface Bus. It was introduced in 1960, and the original idea behind this bus was that we can interface various test equipments or measuring devices like oscilloscopes, multimeters, function generators with the personal computer. The idea is whatever readings or experiments what we have done with these test experiments, we can store those values on a personal computer's hard disk. So we can evaluate, we can analyze those readings later on. So that was the idea behind this particular bus. So this is the schematic view which explains the same thing, that is why a test equipment with the controller or computer. Now you can see in this diagram we have a hard disk kind of a thing or a floppy disk drive along with the measuring instrument. So that is the purpose, that is we can connect a very sophisticated measuring instrument, because in that day it was very difficult to take the readings and store them. So the GPIB bus, or at that time what it was known as HPIB bus, was so powerful that it can interact with the measuring devices. It connected with the computer or known as controller, and it can store the data in hard disk, whatever the readings we have taken with this measuring instrument. So when readings have been over, then we can analyze all those readings, we can do some plotting analysis, and we can do predictive analysis based upon those readings or set of those readings. So that is the purpose of this particular interfacing bus, which was later on taken care by IEEE, and the name specific name for this, that is IEEE 488. These are the connectors for this bus. So this is a male type connector, female type connector. One of them is available on the instrument and one of them is available on the cable itself. If we talk about the architecture within the GPIB, there are three terms which you should be aware of. The first one is GPIB controller, second is talker, and the third one is listener. So we'll start with the first one, which is more important. So whatever application that is being controlled by the controller, so GPIB controller decide which particular device out of the available devices connected with it will work like a talker or work like a listener. Now here talker means the instrument which provides the information. So an instrument which provides the information, so that particular device is known as talker. And listener means the device like hard disk. So these are the devices which are used to listen to that information or store that information. So those devices which receive the information, store, or I should say, or receive the information, they are known as listeners. So we have talkers and listeners, and controller will configure them, either it is behaving as a talker or a listener, but sometime some devices are configured only in one role, that is they are always talker, and some of them are always listener. As I told you, like hard disk, so hard disk cannot send some information to be recorded. Okay, hard disk will be always be used to store the information, to receive the information. So hard disk is a permanent listener. Similarly, there will be some instruments which may be permanently talkers, but there are few sophisticated instruments, okay, which can work as talker as well as listeners, like some sophisticated instrument which gives the function, various functions, like digital function generator. Okay, so it can produce the wave whatever it is required. So at that time it is behaving like a talker, but when the controller is configuring it, or the other device is configuring that it may work as a listener because we are giving some information to it, whether we want sine wave or we want triangular wave or we want a sawtooth wave kind of a thing. So, at that time it become a listener. So, it means each device must be configured with its particular role on the bus. So, this is the block diagram of Gpib bus. So, there are three types of buses we will discuss later on within the interfacing bus. So, but mainly you should know there are three types of devices. One is controller, another is talker, and third one is listener. Now, see how the connector is look like. So, Gpib connector has essentially 24 pins. So, these 24 pins are further divided into three categories. 8 pins are data pins, like here those colored pins are the data pins where the data will be sent, and corresponding to each data pin there will be a corresponding ground pin. So, it means if 8 data pins are there, corresponding to each data pin there is a separate ground pin. So, we have 8 data pins, 8 ground pins, and then 8 control pins are there. Now, out of 8 control pins or 8 lines, 3 will be work as handshake signals and 5 will work as management pins or management lines. So, this 8 further divided into 2 subcategories, that is 3 work as a handshake, but again they all are used for controlling purpose, and 5 are used for management. So, these are the total 24 pins. These are the digital IOs we can use for the data pins. These are the 8 grounds, and these are the control pins. Okay. So, DAV, NRFD, NDAC, these are the, let me write down here, these are the control pins. These are the data pins, and ground pins already mentioned. Now, if we try to find out their functionality and abbreviation, there is a DAV means data valid. So, if this line is high, if this is high for talker, so when talker sends the signal, originates the signal data valid, it means it tells now the valid data is available for the listener to record or to store this particular data. Then not ready for data, NRFD, it is usually low. So, listeners are not ready to listen if this signal is high, you have to make it low once you want to start sending the valid data to the listener by the talker. When the data is accepted, the signal is not data accepted, that is it's a inverse of data accepted. So, it means this again this line should be work in a negative fashion. So, this line should be go low, that is it is not data accepted, that is when it start accepting the data by the listener, this signal goes down. Then we have 5 management lines: interface clear, attention, remote enable, service request, and or identify and or identify. So, there are 2 typical signals. Let me explain. The first is, which is more important, that is attention. So, whenever controller wants to get the attention of talker and listeners, whatever the function they are doing, so first of all they send the signal attention to a particular listener or a talker or a machine. Okay. So, then it start interacting through handshake signals. When the whole process is completed, then it sends the signal end. Okay. Now, the data packet transmission is over. So, these are the functionalities of different pins and lines. This is one of the example of an instrument which is compatible with Gpib bus. So, this particular device is a Tektronix oscilloscope. This is the model number of this oscilloscope. Now, this oscilloscope is available with serial port, that is RS232. Then we have printer or parallel port. This kind of port also have 24 pins, but its function was originally dedicated only for printer purpose. That is, whenever we have a printer, want to print some signal commands out of from this particular instrument, the printer will always be connected at this port, and that is why we have a specific name for this is that is printer port. This is the Gpib port that what we are talking about right now. Now this device is connected to a controller through this cable, and you can see whatever the port that was originally available at the instrument is now available at the extension of this cable connector, so that you can further connected one more connector here and so on. So that is the beauty of this Gpib connectors, that it connects with all the signal, send those signals through the wire, and also get available each of its pin on a further another female connector, so that we can connect further one more connector on the same port. Okay. Drivers available from the manufacturer itself, but being an implementation engineer, sometimes you have to design your own device, your own system. So in that case, LabVIEW is the best solution for you. In that case, you are working like a professional who is designing his own driver for the hardware. So using LabVIEW's instrument IO is similar to designing a driver. So this is very good experience. We will try to demonstrate the same thing through one lab session. So we will again repeat this thing in one of our lab sessions. Students, this is all about Gpib and its interfacing. I suggest you that you go and check proper detail of this bus through the reference material available on the website. I have uploaded few PDF resources related to this, and then try to utilize this information with the lab. So that's all for today's session. Thank you very much.